All right, guys, chapter 8. There's 3 basic scenarios I want you to go through. This is a video of just one of them. This is where we have a angle going to here, horizontal beam coming across, and then a weight hanging off of it. So this might be in a way you can hold a sign, or if you're lifting something and you want to keep it hanging there. So we want to find the tension of A, and we want to find the tension in B, all right, from that. So now, tension of A is going to be directed this way, okay? It's going to be directed up and away because it's counteracting this. And B is going to be directed towards the wall because it's going to be kind of like a compressional force, okay? So we have to break everything down in terms of Y and X. So we want to look at all the forces for the Y. And for the Y, we only have 2 forces that are acting here. And that is this one here, which will be tension A sub Y is going up. And then this here, this is force of gravity pulling on this, which is 200 newtons, okay? These 2 would have to be equal to be in equilibrium, okay? So that's the first one. The X, we have this one goes this way. This is A, this is tension A of X going that way, and tension B counteracts it going that way, okay? So these 2 have to be equal to each other, okay? So tension A minus tension B would equal 0, okay? So when we do this. So the first thing I do is I look at the Y and I say, okay, tension A is this tension here. So it's this force times the sine of 53 degrees. Now the angle we're given is 53 degrees from the horizontal here, which is also 53 degrees from up here because these are opposite interiors. All right, remember geometry? Okay. So you always want the angle off the horizontal. We do not want to use this angle here. We don't want it off the vertical. If I give it to you off the vertical or you see it in a problem, just take its complement. So subtract it from 90 degrees and use that. You always want your angles because sine measures the vertical component if the angle's off the horizontal. If it's off the vertical, then you have to use cosine and it gets out confusing. So if we always keep our angles off the horizontal, then we're good. So tension A, sine of 53 equals 200 newtons because 200 is coming down. All right, divide the sine over, you get the tension in A is 250.4 newtons. All right, so that's what this tension is. Okay, and then for B, now that we have tension A, we said tension A minus tension B equals 0. So if I subtract that over, it would be tension A equals tension B, but it's the X component only. So the X component of tension A would be the 250 that we just calculated times the cosine of 53, that's cosine's X, equals tension B, and you get 150.5 newtons for that. So when you are given a scenario like this, okay, I call it one horizontal, one angled, okay? This is how you solve it, all right? I'm making separate videos for each one, okay?